the networking opportunities here at CppCon are well above and beyond any other C++ conference that I've ever been to.
So my name is Jason Turner. I am host of C++ Weekly. If you're not familiar with my YouTube channel, but I think probably a lot of you are here. And I have written a few books. Some of them are in the bookstore. You can check those out, or you can check them out online. Or, like I said, I've got 2 copies here. I am a developer and an MVP since 2015 for Microsoft. That's just them, honoring me for the contributions to the community, basically. And I do training. And so I just updated this slide like an hour ago. Hopefully it makes sense. If you are interested in having my style of training at your company, first thing is fly me out on site. This is great. I customize the training for your group, probably the most economical thing if you have a large company. And that's just a list of the countries that I've done training in so far, because I had someone be like, oh, we would love to have you out for training, but we're in Germany. And I'm like, okay. Or you can come to a conference workshop. I tend to give workshops at conferences. C++ on C. I did not do CppCon this year, but CppCon and C++ Under the Sea coming up in October, if you happen to be in the Netherlands in 3 weeks. All right, so I do say avoid sitting in the back because I love the interaction. So feel free to move forward if you want to. Do interrupt me and ask questions. Yell things out. I'll repeat it for the room. You can go to the mic if you really want to. This is a little bit less how my normal training days look, but I try to make things as interactive as possible. All right, why this talk? In 2006, I was working on a distributed network scanning system, and I started looking at embedding scripting engine into the C++ project. At that moment, I learned about Swig, and I learned that Python is wrong for embedding. It's got global state. It was never designed for embedding. You can find articles that even say don't embed Python. It wasn't designed for embedding. And then I ended up choosing Lua. 2008, I made this little open source project called the Swig Starter Kit. Not very many people found it except for one of my best and longest clients, actually, who ended up finding this project and saying, hey, we need something like this for us. And I worked with them for 13 years, actually. So make open source projects. You never know what will happen. So the Swig Starter Kit just kind of helped get you set up with using Swig. I'll explain more about Swig in just a second here. I convinced myself that it would be possible to do something that was more automagic for C++ users. And then in 2009, I started ChaiScript with my cousin Sophia. Just out of curiosity, who is familiar with ChaiScript? Whoa, more people than I would have thought. Okay. I have not maintained it in about 5 years now. I got tired of working on it. I left it in a state with very few known bugs, so I don't feel bad about that. Okay, Swig. Has anyone used Swig? Wow, okay, so I see that it's self-selecting for the topic of the room. This is the simplified wrapper interface generator. This can parse interface files that look like header, or you can provide direct header files for it to parse. Swig can generate wrappers to integrate C++ with C#, D, Go, Guile, Java, JavaScript, Lua, Scheme, Scheme, OCaml, Octave, Perl, PHP, Python, Ruby, Scilab, TCL, etc. That's all of them. I have personally used Swig to generate wrappers for C#, Java, JavaScript, and specifically V8 JavaScript engine, Lua, Python, and Ruby. Yeah?
Why V8 JavaScript as C++?
Why did I use V8 JavaScript engine?
Yeah, I mean, C++ and V8 JavaScript are very much connected with Node.js, or?
Oh, okay. So why did I use Swig to generate V8 instead of just directly integrating with V8 engine? Is that what you're getting at? Because this particular project that I was working on, it's that client that I mentioned that I had a very long history with. we started with needing Ruby bindings, and then Python, because of course, if you're a Python programmer, you use C++ libraries. That's just a fact of the world. And then they had other client requests for C# and Java, and then at some point, JavaScript just happened. So a full build of the system had something on the order of ridiculous, like 15,000 functions, I believe, that were exposed to, and you can still build this if you want to, it's still maintained, for C#, Java, JavaScript, Python, and Ruby, and it takes a really long time to generate and link those giant swig bindings. And I've spent too much of my career actually optimizing the CMake build script to make sure that the generation and linking of those bindings were parallelized and there weren't artificial dependencies between them. But anyhow, that's why. Because it was just using the infrastructure that already existed. Okay, so what about Boost Python? Anyone use Boost Python? It's kind of old at this point. There's newer things. There's like pybind 11. But if you go back to my history here, why didn't I use Boost Python in 2006 when I first started looking at this stuff? They're great, but as I said, Python was never intended for embedding, presents cross-platform headaches, and shared global state becomes a problem. If you want to do anything multi-threaded with any of those scripting engines pretty much except for Lua, it's like, right? Because they all have global state, C library kind of things. Which then also brings up, what about Sol2 or luabind? Are you familiar with Sol2? You should be if you have any interest in this stuff, because it's like magic for Lua. Very good. Never used it, but knows what it is. Lua is mature. That's a reason to use this instead of making your own scripting language. Lua is designed for embedding. That's great. If Sol2 were a thing, when I started working on ChaiScript, I probably would not have actually started ChaiScript. So, don't underestimate the power of ignorance. There's, these things existed, and or if they had existed, I might not have worked on it. This has been a big learning process for me. So ChaiScript, a lot of you raised your hands. This is a header-only scripting engine designed for embedding in C++. Automatic function and type deduction, native script function and C++ function interaction. You can easily add a stud function or a lambda or a free function or a member function or whatever to the ChaiScript engine. And then you can write script in ChaiScript and get a standard function object back out if you were so inclined. Full support for exceptions. You can throw an exception in script and catch it in C++. You can throw an exception in C++ and catch it in script if you want to. It just works. It really is. Like, it does work. Now, you said who's familiar with it? Oh, yeah, go ahead.
So back to the previous where you said if Lua had existed before, you wouldn't have written.
If Sol2 had existed specifically.
Right.
Yeah.
Then does that, for those of us that have used ChaiScript,
yeah.
Would you tell us to stop using it and use Sol2 instead?
Okay, so the question was, if you're currently using ChaiScript, would I tell you to stop using it and use Sol2 instead? No, probably not. And I would say that depends on your use case, of course, right? Because the thing that I don't mention here is that ChaiScript syntax was designed to be like C++'s syntax. So if you have, think about C++20 auto parameters and the last version of ChaiScript that I released, there are people who have used ChaiScript as their prototype language to say, okay, did some scripty things, and then you can almost just copy and paste that into C++ and it'll compile. Lua does not have C++ syntax. So it depends a lot on your use cases, but Sol2 does give you a lot of the same kind of magically just works that ChaiScript does. But either way, I'm not trying to encourage you to use or not use any of these projects. Like I said, I haven't really maintained ChaiScript in about 5 years now. But it's just part of the story for why this talk is happening today. Okay, this is a complete and minimal ChaiScript example. I have hello world. It takes a string and returns a string, and inside the script, I append some strings. or excuse me, inside the function, not script. And line 8, I declare a ChaiScript engine. On line 9, I add that hello world function to the script engine. And then lines 11 through 13, I evaluate the script, puts hello world Bob. And this will print hello Bob exclamation point. Complete minimal example with full round tripping of C++ and script. It's amazing, it's magic, yes.
So this is calling the puts function of C?
Yes, that's calling, that's inside script, so it's calling ChaiScript's puts function, which is mostly just a wrapper around puts or cout, I forget at this point, yeah. And yes, so you have interleaved in there a script known string Bob that is calling the registered function hello world, which is the C++ function. The result of that's going back to the script function puts. Yeah?
I'm just interested. How do you return a value from calling a function in ChaiScript and using it in C++?
How do I? Well, let's do that's the point of the talk. I won't repeat the question. Okay, so ChaiScript had a moderate amount of success, and through its development and via bug reports and contributions from users, I learned about template metaprogramming, lambdas, constexpr, static analysis, compiler warnings, because do you know what happens when you ship a header-only open source library? Whatever your users' warning flags are, those are now your warning flags, right? So you basically, if you want to ship a header-only C++ library that people are going to use, you pretty much have to be clean at any warning level on any compiler. Otherwise, people will be angry with you. Runtime analysis as well. This comes down to things that users fed back to me. So if you're interested in some of these things about my learning process, about static analysis and warnings and runtime analysis, then you can come to my open content session on Friday where I talk about tooling as well. Sanitizers, fuzz testing. I learned about all of these things through ChaiScript. It's probably the single most important project I've worked on in my career, actually. So why this talk? Getting back to this. From 2010 to 2023, I consulted on various C++ and scripting projects. C++ Now, I did the talk, why and how to add scripting to your C++ project. Between 2011 and 2017, I ported ChaiScript from Boost to C++11 to C++14 to C++17, learning more about the language each step of the way. Took me 4 years of pondering. Can I make a newer thing that's constexpr friendly and is an embedded scripting language as well? I finally did that in 2023. I created this project called consexpr, which is a scheme-inspired embedded scripting engine with no dynamic allocations, no exceptions, and 100% constexpr capable. You can check that. I don't even have a link to it, but you can check it out if you want to. So, in other words, what I have is a very particular set of skills. I rarely stop to think about this, but I spent more of my professional career around embedded scripting with C++ than any other singular topic. All right, goals for this talk. I want you to understand the challenges of bridging compile time and runtime worlds. I want you to understand one possible solution to this problem. I want you to be able to pick up from a simple example that we will have completed by the end of this talk to build your own simple scripting tool and learn some of the same lessons that I learned in the process. Does that sound like fun? Cool. The goals of the code: as simple as possible, succinct, readable, right? Leveraging the standard library. Non-goals: I don't care about performance at all. I'm not worried about compile times. Not even kind of. You'll see why this comes up in a second here. Well, I'm not worried about binary size. This is not one of the talks from me where we're going to be clicking through Compiler Explorer and looking at how we just cut the binary size in half by adding const, okay? It's not like that. But we'll talk about the trade-offs in both directions. So there's two parts to this. We need a way to register a function with the scripting engine, and we need a way to call that function with runtime known values. Okay. This is our stubbed in script engine. See, script engine. I have a function add. I want to be able to call this add function with the function called add that takes two ints and returns an int, the function called abs that takes a single int and returns an int, function called print that takes an int and returns nothing, and the function called print that takes a string view and returns nothing. So what is the signature of this function add going to look like? A template. That is a fair statement. Stood function, not yet. Yeah.
Pointer to function?
Pointer to function, yes. Yes, okay. How about a template that is to a pointer to a function?
Function ref.
No, we're not going to use function ref syntax here, actually. Not here. You would use that when declaring something like stood function, but in this case, I really just need to know that it's a function pointer. So we have a function that can match functions. It must be a template. I must use template pattern matching like this. This is a function that can match any free function. So this is a variadic template that takes a function pointer. It deduces at compile time what the return type is and what the types of the sets of parameters are. We're going to reach a point in this talk, by the way, where I have more ellipses on one slide than I've ever presented publicly before, just so you know. Okay, does this fundamentally make sense? Okay. There's a lot missing from this, okay? This is level 0. Can anyone point out like the one thing that's missing? Missing the next argument, the string view for this. Oh, yes, yes, I'm missing that. No, sorry, I'm talking about something else. Sorry, with the function pointer. Okay. Oh, repeat the last question. Crap, what did you say? Oh, that I'm missing the name of the function in the add. Yes, and you're correct, but I don't want to go there yet. You just said no except. Okay. What happens if I add no except right here?
Then it only matches functions that are marked no except.
Then it only matches functions that are marked no except. Without no except here, what do I get?
You only match functions that do not match or have no except.
No. The no except functions are implicitly yes. No except function pointers are implicitly convertible to non-no except function pointers. So this right? Okay. What's that, sorry?
I think it was const and no except that would cause me grief with this kind of thing.
Right, yes, const and no except. So we'll get to a more, yes, const and no except caused me grief with this. We'll get to a more complete example of that in a second, yes?
Class methods?
Class methods, yes, that's huge. But right now, so yes, we will get there in just a second. We are at the moment talking about just free functions. So just the ones that I have in my test case. Because if all of your tests pass, then your code is perfect, right? Yes.
Functional templates.
Function templates. Ooh, we'll have to talk about that too. Okay, so this matches any free function pointer right now. This does correctly do that. But I lose the no except property in this case. So if I really want to do this correctly, I have to deal with that as well. You can deduce it, was the comment. All right, no.
With a no except bool, you can have a deducing bool non-type template parameter.
I can have a deducing bool non-type template parameter, but where?
You put no except and
Using
then
the no except.
I can put no, really?
Yeah.
What? I never thought about that. Hold on. What the? Oh yeah, sorry, all my slides interactive. We can just do this. Where do I want to put that? Let's do it here. It's fine, it's all deduced, right? It'll still compile. See, it still compiles. You're saying I can do that? Like you, just for the record, you surprised a whole lot of people, including me. Okay, so which one of these books do you want? I've got the 20, I've got Best Practices 23 and regular Best Practices. Do you want either one of them? Okay. All right, let's shoot. All right, that's cool. I didn't know you could do that. All right. Yeah. Wow, I'm gonna have to remember that one. All right. So we're gonna concern ourselves just with free functions, free function pointers today. But in total, you have to deal with free functions, which does include static member functions. Just for the record, they're the same thing as free functions. Apparently, I don't have to write all of the multiples of no except true and false. But my counting here is both of those, member functions, which includes the combinations of const volatile and const volatile and non-qualified. So that's 4. And reference qualified, R value reference qualified, and or non-reference qualified, L value reference qualified, and R value reference qualified, times 3. No except true, no except false, or I guess we template on them. And objects that have the call operator overloaded, such as lambda or any other callable that someone might pass to you. So 27 if
You know what I'm going to say now, right?
no, I don't know what you're going to say, Ben. No.
Revocable include pointers to member data.
Yes, pointers to member data, it comes up in homework later. You get to implement that your own. We're talking about just functions. Yes, if you want to talk about things that are invocable, as Ben said, then by invocable, like stood invoke, you can invoke pointers to members, member data as well. And then you just get the result back from that. So yes, that is also something that you'll want to eventually deal with. But doing my math, redoing my math, if I can template on no except, then I get 4 times 3 is 12 plus 2 plus 1 is 15 overloads.
Is there a way you can template the reference qualified stuff with using this?
Is there a way that you can template the reference qualified stuff with deducing this? I don't think so. Ask him. I don't think you, I'm pretty sure you can't because it's part of the function type signature. All right, let's go ahead and click down. I'm somewhere between the line of not having enough material and having too much material. I'm not sure. This is just like a start of these things. I've got the member function pointers. Well, at the top, I have the no except. I have one more version than I need. And then working my way down, I've got the const volatile, L value reference qualified, const L value reference qualified, etc. I don't think there's a way to compact these more. I'm still just looking at you. Ben.
Still need volatile? Did we take out volatile?
Volatile's been deprecated for many uses, but I don't know if it was deprecated for member functions or not. Yes? Yeah, member functions is the middle block. Does anyone know if volatile was deprecated for member functions or not? If that was one of the things that was deprecated.
What does it mean for a member function?
What does volatile mean for a member function? That the this pointer, the object itself, had to have been declared volatile, or you must be viewing it through a volatile pointer or volatile reference. It's just like const in that regard. It's just no one uses this. Like, no one uses this. Tuple would be like an obvious use case where there might be volatile in the standard library, and even tuple doesn't have volatile for its accessors.
In 23, is there a way to write this so that it uses the deducing this, and then you wouldn't need the ref qualified?
Right. The question is, in 23, is there a way to write this deducing this? And that's what Ben also alluded to earlier. I don't believe so, because that only applies to member functions, and I'm not writing a member function. I need a pointer to a member function. And in fact, deducing this throws a little bit of a wrench into this work here. Thank you, Ben. What? Nothing. Yeah, well, no, actually, it's funny. We don't actually require extra. Spoiler alert. All right, yes?
What if you have a concept that will match either the type of the class or the volatile of the class or the const of the class?
Could I have a concept? I have actually played with using concepts to reduce the number of things here, and I honestly can't remember how good of a compaction I got with that. I should have looked back at that stuff before I put this together. I've played with it a couple times, and I wasn't ever like really happy with where I had gotten. Okay, so then the final thing here, we have ... because all of the other L value reference qualified and the R value reference qualified, those things all get duplicated again, and then apparently we can template on no except. So we can divide that in half, fortunately. And then lines 18, 19, and 20 are for I was passed a thing that is not a function pointer. I want to add its call operator. Okay, so static member functions, these things are just free functions. This is just going to work how this is, because there's no this pointer with a static function. And what about things with explicit this? Ben doesn't like it when you say that. See, he just corrected you. They're static methods. It works the same way. Yes? The function pointer types are exactly the same as a free function. Yes, so we can do that. They're just like static members. I even put it on the slide. So how did we do this before C++11's variadic templates? If you recall my timeline here, I did this originally in C++98. I'm not going to repeat that for the mic. No, and they said macros. Excuse me. Yes. Okay. Ben gave the spoiler here a little bit. This is the first generation is like this. How many parameters do you want to support? For how many different types of functions do you want to support? Oh my goodness. Rewriting ChaiScript into C++11 saved me so much effort. And then the other thing is Boost PP with lots of macros, in fact. Boost PP is the Boost preprocessor library. You can use it to automatically expand template definitions out. I strongly do not recommend using this mechanism. It was so incredibly difficult to debug the compile time errors.
You know, just as a comment, I think Java doesn't have variadic templates, so it does this until like setting parameters.
Yeah, Java doesn't have variadic templates. Like, no one has variadic templates. I've had discussions with my cousin about how you do a Rust scripting binding like this. You do it like this. With but you still have to expand out. Like, if I recall correctly, you have to expand out how many types and what types of parameters you want. You're nodding very heartily, so I'm going to assume you're correct. Did I wait, I thought what did you say? Oh, the comment was Java doesn't have variadic generics. And I was expounding saying really only C++ does as far as I know, and this usable of a way. Oh, and D does. Okay, that's believable. So this is I'm starting to complete this example. I now have my function signature. I can add the add function. That should compile. Oh, you're right. I still don't have the string view on there. You're right. Okay. All right, now how do I store the functions that are being registered? Standard function. is another way to do that. But we have to expound on this. I need a generic way of storing any possible type of function. What is the signature of a function that does anything look like?
I was just going to say use a stack and then just keep track of the pointer.
Use a stack and keep track of the pointers and things. But if I did that, then I basically have to store like void pointers to all of the functions, and then I have to have some way of like at runtime. Well, I mean, that's basically what standard function does for me anyhow. Stood any. So I need a generic mapping for any type of function and some way to store any possible function to call it later. The first thing that comes to our mind when we think of generic functions is probably templates. But you can't store a function template. You can't get a pointer to a function template, right? For the sake of this conversation,
Clang 13 thinks you can.
Clang 13 thinks you can store a pointer to a function.
Until Clang 13, you can take the address of a generic lambda function, and it says that's fine.
You can take the address of a generic lambda function and it's up to Clang 13. Like of the call operator?
Yeah, you have like if you call operator paren,
Yeah.
generic lambda.
Yeah.
You can take that address and Clang up to Clang 13.
Yeah.
That's good.
Okay, so the comment was that Clang 13 will allow you to take the address of templated generic lambda call operators. That's not right. Okay. So for the sake of this conversation, the helpful mental model is that function templates don't exist. They're not functions, they're templates, right? So instantiations of function templates do exist. Okay, so I need a concrete function, not a template, that can take any number of parameters. I can do this. Return some type, generic function takes a span of types. So span can be 0 to infinity types. Well, it can be 0 to size t objects. What should type be? I heard one answer as standard any. Yes, that's something that can hold anything. This is an important aside. I need to be able to hold any type plus void. Good old void. What's that? Optional any? No. An empty any does work just as well for this use case. Well, I don't actually need to have an optional any. I don't really need to store void, but I have to deal with it because void is, yes, it's a valid return type, but it's also not a regular type. I can't store a void. All right. So my two main choices here, we already said any. My other choice is a variant. I can say I want a variant, I want my type, my input type and my output type, a variant with the possible options of monostate, int, and string view. That covers all of my use cases right here, right? Or I can use any. If you don't use any, you have to know the concrete types at compile time. If you say, I don't like any, I'm going to do something else, you're going to effectively end up recreating any because you need something that you can put on a stack that can hold anything. Yes? You need it to work across translation units? Any can't work across translation units, right?
No, I was
I'm sorry?
asking the choice of type here. Do you need it to be consistent across translation?
Do I need the type to be consistent across translation units? I'm going to say yes, because other things go sad if you try to use your scripting engine and in a way that people expect libraries to work. Yeah. Okay, so the pro to using variant is that I get exactly what I asked for. This is really truly just a pay for what you use scenario. The con is that I have to declare ahead of time exactly what types I want to support. So now my script engine itself must be templated on the allowed types of things that I want to be able to use. And this, by the way, is what cons expr does. I did this. Any is how you really truly make your scripting engine look like it's magic, or you end up reinventing any. Ask me because I did it, right? Pro works with literally any type that can be copied or moved, bless you. You don't have to specify it, it's just magic. Con is if objects are bigger than the small object optimization, you get heap allocation inside of the any. So the any approach, like I said, this is the approach that ChaiScript took. It's magic, trivially easy for the user, just works. The variant approach is the approach that ConsExpert took. So if you really care about these things, you can dig into those two projects and see how I solved these problems on either end of those. But they look awfully similar, really. So this is the approach that we're going to take for the rest of this talk, where I've got a vector of functions that return an any and take a span of any's. Yes?
So why are you storing std function in the vector but not taking a std function?
Why am I storing std function in the vector but not taking a function? Because I need to know the types of the arguments. And then I will create a function because I need to know those types. And we'll get there in just a second. I could do a templated std function and unwrap the types from that. Yeah, I mean, you could do that too, yes. Yes, could do that. No, I don't want you to do that. Sorry. So if I made this take a function, I still have to make my own function like thing that is going to capture that function and knows how to box and unbox the parameters in and out of any. And then I have a function with a function inside of it, and I've done yet another layer of indirection where if I just take the function pointer, I can actually do something that's quite a bit more efficient here. I'm going to default to doing this. Okay, so any questions up to this point? All right. So here is my add function. So I need to write a function that takes a function, returns a new function that's generic and knows how to call the original function. So my add has this function pointer, and in my functions thing, note, yes, functions is global, because, well, I comment on that in a moment. I need to move faster. My templated function called add has functions.pushback, and in there, I'm making a lambda. This lambda captures the function pointer that was passed to it. Yes, there are other tricks that I could potentially do by making the function pointer itself a template argument, and then I reduce the size of the thing, but we're not playing those games here. I play those games in ConsExpert if you care. So I'm capturing the function, and then I am saying that this lambda takes a span of any and returns an any, and I have empty body of the lambda here. Yes? Okay. This is where we start to get lots of ellipses. Let's see how this goes. All right, so this is the lambda that I just talked about declaring. It captures the function f, it takes a span of any's, and it returns an n. This is the lambda that I'm creating. Inside here, I am creating another lambda called invoker. This thing has an implicit capture by reference for all of the contained things, which is just going to be f, basically. Is that right? No, it's going to be params. Sorry, it's going to be params. Inside invoker, I have an explicit lambda template. This is C++ 20. That is a parameter pack of indices. And then I take an index sequence as this parameter. I don't need the name of the index sequence. I just need those indices. And in here, I call func. This code doesn't compile. That should be f. Shoot. So I call f, and I do an any cast to the expected parameter type for each of the parameters in order, expanded with the indices of the make index sequence down here on line 24. Does that make sense at all? Yep. Okay. Like everyone's saying yes. All right, that's spectacular. Then we can move on. So yes, you basically have to do it like this to make sure that they're expanded in the correct order. Each parameter, param type, matches the proper index, whatever. So Those 3 dots right here are doing a lot of work because they're expanding param and expanding index, and if there's a mismatch in size, compile time error. All right. So I assume that the contained type is exactly the same as the parameter type. No implicit conversions at all. This is simple, bare bones. A failed any cast will throw an exception. So if I try to call the wrong set of parameters, runtime exception. If I have the wrong number of parameters, then I have undefined behavior. I could potentially use span.at, but that didn't exist until C++ 26. C++ 20's explicit lambda template parameters are needed to get the index pack. I could have also made that a free function template, but it's nice and concise if I can make a lambda with a lambda in it. No conversions, not even to reference, right? So this is really bare bones. I really need to move faster, shoot. Okay, so I also need, I can store a function now in a generic way and at least theoretically call it, but I now need the arity. I need the number of parameters and the name. Thank you, Ali, since you've been bringing that up. So now I've got my add function. Look, I even rearranged the order of the parameters. It takes a name, and I move that name on line 18. I move that into my map. So I've got a map of name to function on line 13 declared. And then on line 25, I'm using size of ... param to store the arity for this function, because I need to know how many parameters that function needs. And now I can successfully register my plus function. I can avoid using type erasure by capturing function pointers. Let's not cover that. I might prefer flat map, but flat map isn't const expr capable if I was aiming to make this const expr. Probably the most ... dots I've ever put an example on a slide, as I already said. Global's used for conciseness. I'll fix that in a minute. Okay, so to invoke the function, on line 29 here, I can, so on line 28, I'm setting up the parameters that I want to call this function with. I have an array of 2 innies, and it's the values 1 and 2. Then on line 29, I am functions.at plus operator, .callable, that's the thing that I stored, and passing it that array of values. So that becomes the span of any. And then I do an any cast to int to get the output from this thing. And this works. I can execute this code, and I should be able to execute this code. And I should get main returned 3, yes, program returned 3. So I have officially made my tiny scripting engine. I can register a function, and I can invoke a function. Yes?
Can you have overloaded functions, like an add that takes 3 values?
The question is, can I have an overloaded? No, that's your homework. So why jump through these hoops? What has been gained? But all of you already have some interest in scripting. So I just want to know, I think of this as a funnel. I've got all of these compile time known things that I somehow have to smoosh together in something that I can work with at runtime. And then at runtime, I have to expand it back out to the compile time known set of things. It's just kind of what's happening here. I see a couple cameras. All right. Yes?
In your example, when you called that function in main,
Yes.
you had to know at compile time to perform the any cast to int.
I had to know at compile time to perform the any cast to int. I did. I could have tried to cast it to anything else. What's that?
Let's say that at runtime, you're going to pass some type, or you're going
Right.
to infer a type. How would that work?
So if at runtime, I'm going to somehow infer a type. If I really say, like, because C++ is strongly typed, well, statically typed compile time language, if I wanted to have, like I say, I'm going to call a function and I don't know what the return type is, I can store that as an any, but then I'm going to have to do some nasty switch. If it is an int, if it is a float, if it is a string, whatever. It's just the nature of the beast here. You can do something like a visitor and let the compiler expand that out for you with template foo, and I've done that, and it's slow, but it works. Slow compile time, that is. It's perfectly fine at runtime. All right, so let's take a quick look at this. You tell me what I've executed. I'll only give you like a minute. Do you see the deal? I'm pushing 3 values onto the stack, and then I call eval. And eval takes a reference to that stack. Now I know, because I have enough information, that the star takes 2 parameters. So I know I can pop 2 values off the stack and then push the return value back onto the stack. And then I know the minus takes 2 parameters. I can pop the top 2 values off the stack, push the return value. ToString, I know takes 1 parameter, an integer. I can take it, and I can pop the return value, the string, onto the stack, push it onto the stack, and then print takes one thing, string, and I can print that string. Does that make sense? Simple stack-based language. So I've effectively executed this. Print the ToString of 1 minus 3 times 6. So we're getting to something. So if this was my input file, or perhaps this, or if I really just want a very simple stack-based language, my input file can look like this. So this brings us to our new goal. We want to, within the next 13 minutes, because that's where we are, be able to actually execute the script with our tiny scripting engine. Seem like an admirable goal? Okay. These are the rules. If the line is empty, it's skipped. If the value matches a known function, that function is executed. The appropriate number of values are popped from the stack, and the return value is pushed back onto the stack if it's not void. If the value fully parses and is an integer, it is an integer. Otherwise, it is a string literal. So I have value was is a string literal. 1 is an int, 3 is an int, 6 is an int. Star, function call. Minus, function call. ToString, function call. Append, function call. And print, function call. All right, so now we want to register all the functions. Will this compile? I don't remember why I have this slide up. Quick, why is the plus on line 21? Convert it to a function pointer so that I don't yet have to deal with actually matching lambdas. Is that what you're just going to say? Yeah. Okay. So how do I, oh, that was the deal. Print returns void. So will this compile? No. I have to deal with void. So how do I deal with void return type? I make my own void specialization. What's that? Regular. Matt's not here. We don't have regular void. So that's not an option. The simplest way to do it for the sake of this slide is if const expr. If the return type is void, then I return the value of that function. Excuse me, if the return type is not void, then I return that function. Now, I've done many iterations of this over the years, and I prefer having 2 completely different blocks, right? Because on line 8, I can get any RVO that might apply. I don't store the return value and then return it. I just return the thing. Then on line 10, since I can't store the return value, I have to do something. I could have done partial template specialization for a wrapper type of some sort. This I find is the most succinct and readable thing. On line 11, I just return an empty any in this case. That's what gets pushed onto gets returned here. Okay, and eventually you will hit this. You've all already asked about it. This is an overloaded function. Is this going to compile? No. Can't get a pointer to an overload set. That's not a thing. So if you have this situation, you're going to find yourself doing something like this. A static cast of print to a string that takes a print, to a static cast of print to a function pointer that takes a string, static cast of print to a function pointer that takes an int, and registering these under 2 different names. No, we're not going to, yes?
So would your library handle if I created a lambda that took auto?
Nope. So you asked if my library can handle a lambda that takes auto. Not possible, because that call operator is implicitly a template, and you can't get a pointer to a template. You gotta know exactly which types you want to instantiate. There's no way around it, unless I've missed something over the last 20 years. He didn't see me point. It's fine. Okay. So executing the functions. This is my exec function here. I look up the function by name on line 2. I get the beginning of the stack that I want, right? Because I know how deep the stack is right now. I go backward to find the beginning based on the arity of that function. Then I use that information on line 6 to create a span that I pass to the callable. We already saw that working. On line 8, I erase those elements from the stack that I just utilized. And then on line 10, I say if the result has value. If it's not an empty any, then I move that into the stack with pushback. Now, if you've watched my YouTube channel and my stuff, you know that I don't like line 13, but this is one of those cases where I have simply not found a better way to do this, because I have to make that decision of whether or not I want to add it to the stack. You're going to have something equivalent to this. Well, I guess I could pass it to a function and rely on implicit move of the parameter and that. Oh, well, all right. Might be a way to rearrange it. Parsing the script input. This is my parse function. If the input is empty, skip it. That was one of the rules. If it is a function name that exists in my map of functions, execute return. If it correctly fully parses as an integer, the entire string parses in an integer, then it's an integer. On line 16, I push that into the stack of values. Otherwise, I just take the string and I push it back onto the stack as a string literal. Whew. Does that make sense? Moving fast. 7 minutes. So if I put it together, this is what we got. Oh, do you want to? You can do that. That QR code takes you to Compiler Explorer with the completed example. Because as someone else pointed out in an earlier talk, oh no, that was in Norway. Well, it was an earlier talk. It was less than 7 days ago. Because Compiler Explorer is notoriously bad at working on cell phones. I'm sorry. But this is my my entire scripting engine that we just collectively walked through. 96 lines of code. I can register the functions, I can parse the script, I can execute the script, and I can see down there in the bottom right block that it actually did successfully print the value was 42. It works. Complete scripting engine. 96 lines of code, summing up virtually everything that I spent the last 20 years learning about this topic. Hopefully you appreciate that. And we can change the value, and since it's Compiler Explorer, dynamically recompile and execute the code, and the value was 51, now printed. Okay, yes?
You did fairly advertise that you weren't concerned about performance, but would there be any point here to use unordered map versus standard map?
You asked if there would be any point here to use unordered map instead of standard map for the sake of performance. Maybe. And since I did actually get to my it worked slide and I've got 5 minutes left, I will say in ChaiScript itself, which has scoped variables, I've, in many places inside of ChaiScript, I don't use map or unordered map. I actually use a flat vector of pairs of strings to values because it's so much faster to do a linear search through 5 values than it is to do a binary search through it. So there's an argument in basically every direction. You have to decide what you want the properties of your scripting engine to be and go down that road. Yes?
But is it unordered map, is it O of 1 access?
Unordered map is O of 1. I can't recall. Is that right? I believe you. Maybe. Yes. It's a hash with a hash with worst case than it has to compare.
But unordered map is a real hash.
Okay. Unordered map is a real. Yeah. Yes, but yes. So that's the deal. If it's a very small set. So in my script
If it's
you're saying there's like 5 values, linear search is almost always going to win over any of the other options. Yes?
You know what challenges there are getting the bindings working with overloads using a multi-map?
Okay, so the challenges of getting the bindings working with the overloads of a multi-map. Let's see what my next, look. So we have to choose. Do we want arity-based overloading? Do we want type-based overloading? Do we want both? Arity-based overloading is arity-based overloading in this example is weird, right? Because I've got a stack. Do I take the most greedy overload that exists? Do I take the least greedy overload that exists on the stack? I don't know, right? So you can do that or type-based, but in either way, so from my experience implementing ChaiScript, regularly would get bug reports from people. It's slow. And I'm like, yes. And they're like, you know what would make it faster? Bytecode. No, it wouldn't. Because almost 100% of the time in ChaiScript is spent in overload resolution. At runtime, I have to say, I was passed 3 parameters. What are their types? What set of functions do I have registered that take 3 parameters? What types do they expect? Are these 3 innies types that can be implicitly convertible to those types or not? It's incredibly expensive. By far the easiest thing to do is say, I'm going to play the game that basically every other language does and say, I don't allow type-based overloading. I mean, what languages besides C++ allow type-based overloading? D? What's that? Julian? Java? C#? Any functional language with static polymorphism. Okay. So my point being, it's relatively easy for us to count the set of languages that have type-based overloading. Yeah, functional languages. C doesn't, Rust doesn't. Rust has what, trace-based overloading, but it's a different beast. None of the scripting languages do. As far as I know, ChaiScript is the only scripting language that has true type-based overloading in it.
Python by technicality.
Python by technicality.
Because it's dynamically typed, you can give it anything and it'll just work.
Well, yeah, but you still can only give one function declaration, one function with that name, right? You can't have 2 functions with the same name in Python.
And if you do like module weirdness or
Oh. Okay, the comment was module weirdness in Python. The point is, it's complicated to do, and it's expensive. Type-based overloading, like we just said. Hard, expensive. Tools like Swig work like this. Uh-oh, we have 1 minute left. What is this function doing? Quick. This is directly extracted from Swig-generated code. No, both of the branches actually check to see if argc equals 1. So in the top block, if argc equals 1, then it tries to unpack that element as an int. If it is able to unpack that element as an int, then it calls wrap print swig 0. So in other words, it calls the version of print that takes an int. On line 12, still checking to see if argc equals 1, then it tries to unpack argv0 as a string pointer. If it succeeds there, then it calls print swig underscore 1, which is the overload of print added when it takes a string. This is exactly what you have to do in your own scripting language if you want to do this kind of thing. You have to make these runtime choices. All right, your homework. Add overloading support. Add more structure to my scripting language. Add member function support and member object support. See what reflection would gain you, if anything. Remember to test, particularly with fuzz testing. It's very easy to create dangerous scenarios when parsing user input. Do you see my joke? This is directly related to something that took down the world, okay? Yes. Here is the Compiler Explorer version of your homework. You can take that link, and this is a version of this that is actually expanded with comments. I know I'm out of time. And expanded with comments and more details, and actually has one conversion. You can register functions with references, and it works correctly. It's very exciting, yes. It just drops CVRef. And this is the gist version of it if you just want the plain source code. I know, I'm still out of time. I'm gonna, you can ask me for that later, and just for the record, you can get in contact with me like this if you want to. Thank you very much. Sorry for going 1 minute over.